calculator, it's in rectangular mode. Okay, so we want to change this rectangular grid to polar. You're going to go to the wrench here to get to your graph settings. And where it says grid, you want the grid to show, but right now it's the rectangular grid is selected. So you just need to select the polar grid. Okay, and when you do that, it's going to be in radians. Okay, and we want to put it in degrees. It's going to be a lot easier for y'all to do these in degrees, I think. Okay, now hopefully when you do that, this graph looks like a circle. Okay, some people's computer screens are different sizes, and somehow, you know, zooming in or out or doing something, some people's get distorted and it doesn't look like a circle anymore. It looks oblong in one direction. So you can always go here to your X maximum and minimum here, the range and the domain of what the screen shows, and reset this. The y-axis is always going to be smaller than the x-axis what's showing because it's not a square screen, right? Okay, if you set them to be the same, it's going to be distorted. It's not going to be a circular grid. You all understand that? So just play around with these numbers if your graph is not circular. And if you have the touch screen, I think you can actually put your fingers on points on like the axis and, you know, use your fingers to zoom in and out and change the size. Okay, you can also use the plus and minus here to zoom in and out. You can click and drag and move the graph around to look at different parts. Everybody okay so far? All right, now to actually graph your equations. You are not going to write down some random equations on your paper and then try to graph them and just hope it looks good. Okay, I want you to use Desmos. You can input a bunch of equations over here and see what they look like. Okay, and every equation that you add to the same grid will show up as a different color, so you can see what curve is part of which graph. Now that will show what it looks like if they're all overlapping on the same grid or at the same orientation. You could still do them on separate polar grids, but when you go to glue them down, if you don't turn any of them, if you keep them the same direction, okay, this screen will show what that would look like. Okay. All right, so tell me, pick a polar equation. What shape? What shape do y'all want to look at? A rose? Okay, I heard rose. We'll do some others in a second. All of your polar equations have to be in the format of R equals. Okay, so you type in R equals, and if I'm doing a rose, that's going to be A sine or cosine of n theta. So some number, I'll just pick a 2, okay, and then sine or cosine, it doesn't matter, of n theta. There has to be some number in here with theta. So how many petals do y'all want? 3? So it would be 3 theta, because remember, if it's n is odd, that's how many petals there will be. You go to the keyboard to ABC, and theta is here on the right. Okay, so here is 2 sine of 3 theta, and I can zoom in a little. Okay, so 3 petals, and it's a sine function, so it does not start at the polar axis. If I wanted to change that, I'm like, wait, that's not what I was picturing in my head. I was picturing it starting here on the x-axis. You can go and change this to cosine. Now you've got a petal on the x-axis. Okay, or you could say I was picturing it to be bigger. I want those petals to be longer. So you would change the A value from a 2 to like a 4. Okay, and it gets bigger. So you can just go in here and type an equation and kind of manipulate it until it looks like what you want. Now for the range of what it's showing, you typically want this set 0 to 360. You want to see a full rotation of what that curve would look like. Okay, now sometimes it'll make a difference, sometimes it won't. Okay, like when I changed that from 180 to 360, it didn't change this particular graph. Okay, now you can say, okay, now I want one going in the opposite direction, like overlapping this, 3 petals, but I want that instead of going to the right, I want this petal to go to the left. Okay, so to change that, I'm going to copy and paste this. I just need to make it, instead of a positive cosine, I need to make this negative. And there, it flipped it over. Okay, so that's two separate equations with two separate rose curves with 3 petals each. Okay, I could have also done this. This is 6 petals. I could not have done this with an even number, because remember, anytime you enter an even number, it doubles the petals. So there is no way to do this with one, there's no way to do 6 petals with one equation. I had to do it as 2 separate equations to get 6 petals. Does that make sense? And you could change it if you don't want them all the same length, make one of them a little shorter, give it a little dimension there. Okay, I still need a 3rd equation, and it does not have to be a rose. When I say you need a rose curve, that doesn't mean the flower has to only be rose curves. You can mix and match the polar equations within one flower. So I could add a circle to this, or a limicon, or a lemniscate, or a spiral. Okay, you can mix and match the shapes that are within the same flower. So let's say I want that to be even. I want them to be the same. So I'll change that back to a 4. What if I just want a circle here in the middle that I could color in to be like pollen or something, you know? What is the equation for a circle centered at the pole? It's just R equals the number that's the radius of the circle. So however big I want if I want it to, this is 2, right? I can zoom in and see. Okay, so this is 1. If I want it real small, this is half. Okay, so I'm going to do half, 0.5. And that puts a circle right there. Or if I want it a little bigger, I can make it a 1. And there's a little bigger circle. Okay, I think I like the 0.5 better. So there you go. There's one of your flowers. But you can get more intricate. You could add more petals like in between those, right? Okay, to get them at a different angle, you would have to change the cosine to a sine. So I could say, I'm going to do this one again, but I'm going to make it sine. See, that added petals here. And then I could do it again and make it positive sine, and that added petals here. So now I've got a whole bunch of petals there. That's 12 petals. That's 5 equations for that flower now. And you can see the different colors so you know which is what part of what equation. Whenever you're happy with the image you see here, okay, if you decide, yeah, I want to use that equation, write it on your paper. Please use a pencil because you may decide to change something later. Okay, so use a pencil, write your equations on your paper. Okay, now to actually graph it on your paper, on the paper grids, the one thing Desmos doesn't do, or at least I don't know how to make it do it, that the calculator, the graphing calculator does, is give you a table of values to actually plot points. So what you could do is you could take one equation at a time and put it in your graphing calculator in y equals, you make sure you're in polar mode, it'll be r equals, okay, and go look at your table of values there. And I would probably set the change in table. So I'm going to do this first equation, 4 cosine of 3 theta. Okay, go to second window, and I would have the change in table be 15 degrees. Okay, when we were doing spirals, it was set to 45, but for these other shapes, you should set it to show every 15 degrees. So then when I go to look at the table of values, I have more points. I can plot a point at 0 degrees and at 30 and 45 and 60 and 90. Okay, so I can actually get the width of the petals correct. Now your other option, if you're trying to do this at home and you don't have a graphing calculator, okay, so you can't go look at that table of values. Okay, once you have them all written down, knock it down to where you're just looking at one at a time. And zoom your graph in. Just go zoom in and say, okay, that's a point at the pole. The end is at 4 on the polar axis, right? And then get maybe like 2 more points on each side of the petal to get the width right. Say, okay, at this line is 15 degrees. It's here between 2.5 and 3. So it's at about 275 or 2.8 at 15 degrees. Okay, and that mirrors over on this side as well. And then you could be like, okay, between the 15 and 30 degrees, okay, it's at about 1.75. Y'all see what I'm saying? Just zoom in and get some points and see at what angle, so you can get the width of your petals correct. Same thing when you're doing a limison. You want to get the width, how wide that is, or how wide the inner loop is, or whatever. You want to plot those points. When we were doing these just as basic sketches on those worksheets to practice, you were only plotting 3 points. You were doing the 3 end points of the petals. And then you just went through and did this, right? These need to be more accurate than that. Okay, so you need to zoom in and get some points, or use that table of values in the calculator to get some points to plot. Okay, so here is another shape besides a rose or a circle centered at this pole. A lemniscate, remember in our papers, we were writing those equations as r squared equals. This will not let, I mean, it will let you square the r. Like you can use the keyboard and make it squared and then try to put your equation in, like, and then a lemniscate is 2 theta. Okay, so you could try to do that where a is 3, right? Because this is a squared. So I'm trying to draw a lemniscate along the polar axis, because it's cosine, with a length of 3 for each side, but it's not graphing. It's giving me this error. It's saying polar equations must be linear r. That means the r can't be squared. Okay, so how would I get rid of this square to solve for r? I would take the square root. So instead of having r squared equals this, I can put r equals the square root of this. So I can get rid of the squared and put all of this under a square root. Oops. Okay, and now I have that shape, that figure 8 I was looking for. Okay, so if you're wanting to graph a lemniscate, that's the format you're gonna have to put it in. Okay, now a limison, there's 4 different types we talked about. Remember, this is the one where you have some number and then plus or minus another number and then sine or cosine of theta. Okay, so this particular one I just wrote out. Oops, I don't know why I'm doing that. This out. Okay, this one is a limison with an inner loop. It's going up because it's positive sine. Okay, and 3 plus 2 is 5, so the top is at 5. And 2 minus 3 is 1, okay? And it's negative, so it's 1 in the same direction as the height. So that one loops in. Now, if you want to make a cardioid, these 2 numbers have to be equal. So I could change this to both be a 3 or both be a 2. And it makes this a cardioid. It comes back into the pole instead of looping inside. Now, if I want it to be dimpled, the A needs to be bigger. So I could make that a 3, and now it comes out from the pole in the opposite direction of the height, but it dimples in still. Does that make sense? Now, I don't want you, if this is the graph you're going to use, I don't want you to just put the height, the lower point, and the stretch along these axes. I want you to go and get a couple points up here and down here as well, because I want this actually to be the right size. Y'all follow? Okay. Now, if you wanted it to be convex, if you don't want it to dimple in, this number has to be double this one or bigger. So like if I make that a 5, okay, now it is convex. Or if I make it a 4, It's still convex. It looks like it kind of flattens out there instead of dimpling in. Do y'all follow? All right. And then whatever you decide, like if I decide to go back and make that an inner loop one, you could rearrange this. Somebody was asking in another class, you can't repeat equations. Okay, so I can't, if I use this equation in flower 1, I can't use this equation again in flower 2. Okay, if you add extra equations, you can repeat equations, but they won't count as extra credit because they're not extra, you're repeating. Does that make sense? So it has to be a different equation. However, if I do something like this and I just change this plus to a minus, that is a different equation, even though I made just one little tiny tweak. Look at the graph, it's different. So that counts as a different equation. Okay, or I could make a little tweak of changing sine to cosine. Okay, and then I could make a little tweak of changing that minus to a plus. So I have positive sine, negative cosine, positive cosine. So that's 4 separate equations. And that makes a pretty cool looking shape. Maybe you want to put a circle around it all. Okay, those go out to 3. So maybe you want to do r equals 3 and circle it all in and make that your flower. Okay, so you can manipulate and add equations until you're happy with the way it looks. Now you do have to be able to graph this on the polar coordinates. Okay, but you could do all 5 of those separately, and then when you glue them down together, it overlaps, or you could do all 5 of those together on one grid. Any questions so far? Y'all kind of get how you're going to just play around in Desmos until you're happy with your shape? Okay. If you leave Desmos and you go back, you're going to have to go back to those settings and reset it to polar and degrees, because it automatically, when you open the website, it's going to be in rectangular form. All right. So have fun in Desmos and design today and figure out what you want your equations to be. When you're happy with what the equation is, make sure you write it on your paper, that lime green paper, the rubric on the back. Make sure you're using a pencil in case you have to change something later. Okay? And make sure you read thoroughly through the instructions so that you make sure you are including everything that needs to be included. All right, so those of you in class, y'all are free to start researching. I'm going to keep talking over here because I'm going to keep recording this video to go through the rubric on the video for people who are absent, okay? So I'm going to be talking over here, but I'm not talking to y'all anymore. Y'all can get to work. There's a bunch of supplies in the front of the room, a bunch of different size grids. They're from a real big one that takes up the whole paper down to smaller ones. You get to pick what size grids you use. There's construction paper for the background, and there's scissors and glue and all that good stuff. I doubt anybody gets to needing to cut or glue today. Probably won't be till next week, but all the supplies is up there. Okay, in the video, those of you watching this at home or just coming back to this video to review, yeah, let me pull up the rubric. Okay, so in class, you're getting a hard copy of this and it's on like a bright lime green paper, so you won't lose it. Okay, but you're being tasked with creating a bouquet of flowers of polar equations. Okay, this goes through the details of what has to be included. You have to have 5 flowers with at least 3 equations each, plus some sort of vase or container. Okay, there's stipulations like you have to use both sine and cosine functions. Okay, not all of your equations can be one or the other. There has to be a mixture. You have to have roses with odd and even numbers of petals. Okay, so that means you need at least 2 roses. It can be 2-dimensional, like you'll draw them, cut them out, and glue them on paper. So it'll just be a flat paper you turn in with your arrangement on it. Or some people want to go a little above and beyond, and they make it kind of 3-dimensional by cutting like making a vase or getting some sort of container and putting the flowers on actual stems like pipe cleaners or popsicle sticks or something and creating an actual arrangement. But that's up to you. It's due next Friday, so we have a week to do this. And late projects will lose 10 points per day that they're late. And this is your first test grade. It's a major grade. Okay, here's how you will be graded. So you can go through and make sure you have everything before you turn it in next Friday. If you go through this looking at your project and checking, you should pretty much know what grade you're going to get. There is an opportunity for 10 bonus points maximum. That can be from the presentation or creativity, going above and beyond on that portion. And also, if you're not artistic or creative, or you don't think you're going to get extra points doing that, you can still get extra points, bonus points, by doing additional equations. So on the back of this is where you're going to record the equations for each flower. Okay, you'll tell me what the shape is, like if it's a rose, a circle, a limison with an inner loop, or a spiral, etc. And you'll have the equation written, and you can see there needs to be 3 for each flower and 1 for the vase. So that's a minimum of 16 equations. If you would like to get some bonus points, you can add additional equations to flowers. Okay, so you can just write them underneath. Okay, you'd have to write the shape and the equation. And you can do that for multiple flowers. You can add on a completely separate flower, just somewhere in this extra white space, make a little table and put like flower 6, flower 7, or flower 8, however many flowers you're doing. Some people choose to do something completely different, like they make a butterfly or a snail or leaves on the stem of the flower with different separate equations. And you would just write that in here. Now, I need to know which one is flower 1, 2, 3, 4, 5 on the paper. So make sure that that's labeled on your paper when you turn it in on the actual project. Label which flower is which. And I need to know where the polar axis, where is 0 degrees, because when they're glued onto the paper, you may be gluing it on at an angle. You may have rotated it or something. So it needs to be marked somehow where the polar axis is, where is 0 degrees, okay? And that can be done by actually writing 0 degrees on the polar axis, or just bolding the polar axis on all of your graphs so I know how to orient it when I'm grading. And if you are scaling your axis, if you are not counting by ones, you need to label what it's scaled by, okay? Or put a note here next to flower 2, put scaled by 5 or something like that, okay? If you have questions when you get back to class about the project, of course, I can go over that. I'm going to turn the camera on here in a second and show you some examples, and they're available when you get back here in person. You'll be able to see these. I'm going to show you some that I just have handy here on my desk, but there's others at the front of the room you can see when you get back to campus. Okay, so let me turn this camera on. Okay. All right. So I'm going to pull this over to the screen so you can see these examples. So when I was talking about 3-dimensional, here's some examples of what I mean. Like people actually cut them out and put them like in some sort of vase. Like this one's using straws to hold them up. This one's using little wooden dowels. Okay, so they just like actually made little bouquets. And there's a bunch more. I'm going to tilt my screen up above my bookshelf back there. Up there, you can see it. Those are some of the other. Those 2 were done like on a canvas. They like painted the background and then like glued their flowers on there. And then there's a bunch more like 3-dimensional ones. Now some of the more typical ones, they're just like on paper. So you'll get blank polar grids and you'll draw your equations and then you'll cut them out and put them on a background paper to create your arrangement. You can see here is labeled, like they labeled this is number 1, this is the number 5, and you can see they labeled where the polar axis is and that what they've scaled by, so I know how to grade it. Okay, here's another example on paper, and you can see they've labeled their scaling, they've labeled their flowers with the little numbers, and then here's a good one that shows. So you can see they put a 0 degree on each, so I know how to orient this when I'm grading. So they actually glued theirs on where 0 degrees was to the right every time. They didn't glue theirs on at an angle. So that one was pretty easy to grade. But if you do glue them on at an angle, like, let me find one. A lot of these are glued on at angles, but they didn't label them correctly. So I want to show you how it should be done. Okay, so like this person's, they see how they're not all straight up and down, all their flowers. So if I get up closer to this one, you can see they've labeled like their 0 degrees for this one is up here. So that means I need to turn this flower this way for this to be the polar axis, and then I can check it. Okay, and then this one, the 0's over here, so I need to turn it back this way to check it. So they can be glued on at different angles and directions, and that's fine as long as you label it so that I know how to grade it. The other thing that I showed the class in person is there are some people within one flower, for instance. So they used 3 equations and they did it on 3 separate grids, 3 separate pieces of paper. And then they cut them out and then they glued them on here together to create a flower. Okay, same thing up here, these rose curves. This is 3 separate grids, and then they just glued them on here on top of each other to create that flower. So you can do all your 3 equations. You have to have 3 equations per flower, but you could do it on 3 separate grids and then glue it together. Or the other option is to do your separate equations all on one grid. Okay, and I need to see the outline of all of them. This one is not, I mean, it looks good, but these should be curves. They drew these very pointy, which is not what it's supposed to look like. The polar graphs are supposed to be curved, but you get the idea that they did it all on one piece of grid paper and then just shaded and colored how they wanted it to look. Now, if you're doing it all on one grid paper, that's fine, but I do need to see the outline of all the shapes so that I can grade them all separately. Let me see if I have another one like that. I know I have some up front in the front of the room. Okay, this person did them all on one grid and then shaded them in. So you can see, like, this is all of these different shapes are on one grid, and then they're colored separately. But I can still, like, I can see that spiral over the top of these limaçons. Okay, and I can see these limaçons behind the rose curves. Now this one is a little harder. Okay, I don't recommend this because they colored so solidly over the limaçon that I can't really see where the bottom points of the limaçon are. I would like to still be able to see that outline because I can't tell looking at this since it's behind there. I can't tell if that looped in or was dimpled or convex. I can't tell. So if you are overlapping them like this, I still need to see the outline of that other shape so that I can grade it accurately. You can see a lot of people are a little more artistic and do like nice, pretty like shading, and some people use like markers, some people use matte pencils, some people use crayons, oil pastel. I think this person used oil pastels. But you can do whatever you want. Be creative, have fun with it. But that's the gist of the project. Okay, you can let me know in person if you have questions. And like I said, I have a lot more examples up at the front of the room in person that you can view. All right. And it is due next Friday. You're going to have 4 class days. We have today is Friday the 14th. And then you will have Monday off of school. So then there's 3 more days next week that we'll be working on the project, and 1 day next week where we'll be taking a quiz. Okay, so the project will be due Friday by the end of class. So if you don't think that's enough time for you to finish it, you need to be working at home some, either over this 3-day weekend or in the evenings next week, or afternoons and tutorials or something. I think that's it. I think that covers pretty much everything that I talked about in class, instruction-wise. So hopefully those of you who weren't here today still understand what you're doing.